I'm Han Zhang, distance student from CSE 8313, and my topic is From Object-Oriented Design to the Use of Service-Oriented Architecture in Cloud Computing. As modern software development techniques evolved around the use of object orientation, however, there's an increasing drive to develop applications using distinct services. This would facilitate the reuse of already developed business processes by using functions but not objects. As you can see that the object orientation and service orientations are different from these several aspects: the communication, the standards, and the complexity. Object-oriented is a programming paradigm whereby state and behavior are grouped together into real-world artifacts. This seems quite natural as one of the core principles of object orientation is that data and behavior should be co-located. That is to say, the behavior is responsible for the data that it needs to operate on. While service objects are great, it might take you some time to ship your man that classes can actually be verbs, but instead of representing a piece of the real world, they actually represent actions in the real world. Service-oriented architecture is essentially a collection of services. These services communicate with each other. The communication can involve either simple data passing, or it could involve two or more services coordinating some activity. Some means of connecting services to each other is needed. Well, service-oriented architecture offers us some positive benefits such as the languages, neutral integration. It's the foundational contemporary web services standards use XML, which is focused on the creation and consumption of the delimited text. Despite the development languages used, these systems can offer and invoke services through a common mechanism. Programming languages neutrality is the biggest difference from past integration approaches. The second is the component reuse. Given current web service technology, once an organization has built a software component and offered it as a service, the rest of the organization can then utilize that service. Thirdly, the organizational agility. SOA defines building blocks software capabilities in terms of offered services that meet some portion of the organization's requirements. These building blocks, once defined and reliably operated, can be recombined and integrated rapidly. The last is the leveraging existing systems. We can see that the most compelling business case for SOA is often made regarding leveraging this legacy investment. Thus, it can enable integration between new and old system components. There are also some considerations out there with service-oriented architecture. Let's see the dependence on the network. SOA attempts to streamline integration across systems by providing components that are architected and described in a consistent fashion. Well, SOA is fundamentally dependent on the network to connect the service provider with the consumer. Poorly performing networks can make a large impact on the availability of web services to the consumer. The second consideration, the provider costs, as creating a generic reusable software component for a broad audience takes more than creating a less generic point solution. The cost of reuse therefore shifts to the service provider, which in turn benefits the consumers. The third is the enterprise standards. When many components are being simultaneously developed by individual teams, it becomes critical for the interface of a provider service to match up to the call of a consumer. That is to say, choosing and communicating a comprehensive set of enterprise standards is a responsible approach to aiding enterprise SOA integration. Now it comes to the cloud computing. From its official definition, it is a it is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources, which can be rapidly provisioned and released with minimal management effort or service provider interaction. We can see that cloud computing describes a broad movement toward the use of wide area networks such as the Internet to enable interaction between information technology service providers of many types and consumers. Service providers are expanding their offerings to include the entire traditional IT stack, ranging from foundational hardware and platforms to application components, software services, and the whole software applications. As we can see that there are quite several types of cloud service, but the common thread in cloud computing offerings across all levels of the stack is the consumer and provider relationship and a dependence on the network to connect the two parties. The figure depicts a sampling of current commercial vendors with cloud computing offerings. The offerings fall into the same general grouping as the Cloud ID stack described earlier in the previous figure, with foundational service on the left and more complex services on the right. And also please note that this marketplace is dynamic and continues to grow rapidly. When cloud computing and service-oriented architecture comes together, I would like to cite this saying to describe them. It's the while you can certainly leverage a cloud without practicing SOA, and you can leverage SOA without leveraging cloud computing, the real value of cloud computing is the ability to use services, data, and processes that can exist outside of the firewall. Cloud computing and service-oriented architecture have important overlapping concerns and common considerations as shown in this picture. The most important overlap occurs near the top of the cloud computing stack in the area of cloud services, which are network-accessible application components and software services, such as contemporary web services. Both cloud computing and service-oriented architecture share concepts of service orientation. Services of many types are available on a common network for use by consumer. Cloud computing focuses on turning aspects of the IT computing stack into commodities that can be purchased incrementally from the cloud-based providers and can be considered a type of outsourcing in many cases. For example, the large-scale online storage can be procured and automatically allocated in terabyte units from the cloud. However, cloud computing is currently a broader term than SOA and covers the entire stack from hardware through the presentation layer software system. Yeah, that's pretty much of it, and thank you for watching.